Okay, so now we're going to look at C2H2. Let's get a new piece of paper. Okay, so first things first, let's count up our valence electrons. For carbon, again, we're in row 4A, which means we have row 4A, 4 valence electrons. Our chemical equation says there's 2 carbons, so we'll times this by 2 to give us 8 valence electrons. Hydrogen is just in row 1 or 1A and contributes 1 valence electron. There's 2 hydrogens here in our chemical equation though, so that will give us 2 valence electrons from hydrogens for a total of 10 valence electrons. Now, determining the central atom in this molecule is a little tricky, mostly because it's an even number, so there's not really a central atom to speak of. But we can say, since carbon can form more than 1 bond, we know that carbon can form up to 4 bonds, that carbon is going to be the central atom because it can form the most bonds. So the carbons must be bonded to each other. And so we're going to illustrate that next. Okay, so we know that the hydrogens are bonded to the carbons because if they were just bonded to themselves, they wouldn't be part of the molecule. So we know this is going to go H bonded to C, and this C has to be bonded to the other carbon, and so this other carbon is going to be bonded to the other hydrogen. So since we drew out the structure, we're able to count up the valence electrons that have been used. So 2, 4, 6 have been used in these bonds. That means we have 4 of our 10 valence electrons left. Next, we want to check if our octet or duet rule has been satisfied for each of these atoms. For our carbon, we have 2, 4, so no. This carbon only has 4 electrons, so no. This hydrogen has 2, so its duet is satisfied. And this hydrogen has 2, so its duet is satisfied. All that's left for us to do is distribute the remaining 4 valence electrons and see if we can satisfy the octet rule of these carbons. So let's go ahead and draw in our remaining 4 valence electrons. We'll just put them evenly across both the carbons we have here. So 1, 2, 3, 4. And now we've used all 10 of our valence electrons. And we need to check our octet and duet rule. Carbons are still not satisfied. So they have 2, 4, 5, 6 each. So they're both missing 2 electrons. And the hydrogens are still happy. So how can we satisfy the octet rule here for carbon? Well, we're just going to form a triple bond between these two. And let's see how that works out. Okay, let's draw this out. So we have a hydrogen bonded to a carbon. This carbon is triple bonded to another carbon, which is bonded to a hydrogen. Each bond represents 2 electrons, and we have 1, 2, 3, 4, 5 bonds, so 10 valence electrons used, meaning we have no valence electrons left. For our hydrogens, they're both still happy with their duets filled. And for the carbons, we have 2, 4, 6 from the 6 valence electrons just from this triple bond, and then 2 from the hydrogen, the bonds to the hydrogens. So now we have 2, 4, 6, 8 for this, and 2, 4, 6, 8 for this carbon. So our octet rule is satisfied. Now we can try to get a model made of this. Okay, so we're going to put this model together. I have carbon, carbon, hydrogen, hydrogen, single bonds for each of the hydrogens, and this carbon here has a triple bond, so we're going to use 1, 2, 3 of these bendy sticks to get that put together. So let's start with the carbon. I'm just going to put all 3 of these here. And then we will put on the hydrogens. And you can see that looks pretty linear. So yeah, this is acetylene, actually, is the common name for it. You use it in acetylene cutters and gas. And yeah, it is a linear molecule.